Okay, 3 problems in this video. 31 and 32 are coming in later slides. How do we deal with this problem? What's the solution to the equation? Well, we're going to isolate the variable, and the first thing that I'm going to do in order to do this is to take away this 5x from both sides. Because I know that if I do that, just looking at it, once you get experience, you can say, well, if there's 6x here, and I take away 5x from both sides so that they're no longer on this side, then 6x minus 5x just gives me x. And that's good because I want it to be down to a single one of the variable. So that's going to be my suggested way of approaching this. Subtract 5 from both sides equals 5x minus 5 minus 5x. As I keep saying, everything that's already there goes first, then what you're doing, in this case minus 5, afterwards, equals everything that's already there goes first, then what you're doing, minus 5 at the end. Resolving this, 6x minus 5x is x. There's still that minus 3 equals 5x at the start and the negative 5x at the end cancel out to leave us just with minus 5. And now we say to isolate x, we need to deal with this negative 3 with a positive 3, plus 3 on both sides. And we get x equals negative 2. And let's do a proof on that. I'm going to do the proof right below it, just in a different color. It's easier for me to write. I'm left-handed, so it's easier for me to write over here on this side. And we get 6x minus 3 equals 5x minus 5, where 6 parentheses negative 2, minus 3 equals 5 parentheses negative 2 minus 5. And distributing through, I got 6 minus 2 is negative 12. Minus 3 equals 5 times negative 2 is negative 10. Minus 5. Negative 12 minus 3 is negative 15. And negative 10 minus 5 is also negative 15. Done. Okay, let's check out number 3. Okay. What do we need to do to get the variables all on one side? Well, the constant is already on the left-hand side, and there's no constant here, so it doesn't make sense to move this. We just leave the constant on the left and get rid of what's there to get all the variables on the right. So we've got 6 minus t, and let's say plus t, to move that away, equals 2t plus t. Oops. And now we've got then 6 equals 3t, and dividing both sides by 3, 2 is equal to t. And I'm going to do the proof right below. Say 6 minus t equals 2t, or 6 minus parentheses 2 equals 2 parentheses 2. 6 minus 2 is 4. 2 times 2 is 4, so 4 equals 4. Done. Not bad. That was a pretty short one. Let's do one more. Okay. What we're going to do here is, well, I like to have, we're going to need to move the variables to one side and the constants to the other side. There's variables and constants on both sides. So I always like to deal with positives if I can. So I know that if I undo this minus 6x with a plus 6x, and that adds 6x to this, and it puts us into positive x's. Just for some reason that I always just like that a little bit better. Less confusion with negative numbers. So we say negative 4x minus 9, and then we add 6x to this side. The other side we say negative 5 minus 6x, it's already there. Then add 6x rather, to this side as well. Okay, combining these like terms gives us 2x minus 9 equals, combining these like terms cancels them out, so we just left with negative 5. Okay, now we have to add 9 to both sides to isolate the 2x's. 2x minus 9 plus 9, negative 5 plus 9. and we get 2x equals 4. Or 2x divided by 2 equals 4 divided by 2, giving us x equals 2. And let's do a proof. This part's kind of sticking over a ways, so I'm going to just start my proof a little lower than that. I'm going to say proof negative 4x minus 9 equals negative 5 minus 6x. Negative 4 parentheses 2 minus 9 equals negative 5 minus 6 parentheses 2. And I'm going to do all the multiplication on both sides first. So negative 4 times 2, 8. Sorry, negative 8 minus 9 equals negative 5. Negative 6 times 2 is negative 12. And now I do the subtraction. Negative 8 minus 9 is negative 17. And negative 5 minus 12 is also negative 17. So that is a quality proof because it worked. Okay, that's it.